So on 17 here, they are giving us an equation. They're talking about where is the graph decreasing and concave up. So to talk about decreasing, which derivative do we want? The first derivative. So the first thing I did was I found the first derivative right here. Okay, I found that first derivative. And then to talk about increasing or decreasing, I needed to make a number line. All right, so I had to find f prime. So I took the derivative. Everything had a 6 in it, so I divided a 6 out. And then I set it equal to 0 and solved. So x squared minus x minus 2 became this thing. Set it equal to 0. My two values became -1 and 2. Those were the two values that I checked because I had to change the signs there. So I made my number line. I plugged in some values. Which equation am I plugging in to make this number line of f prime? I'm plugging it into the f prime. So I took -1 and plugged it in here. And I took 2 and I plugged it in as well. I did the same thing there. And so I found out where it was positive, negative, and positive. All right. So the question was, where is it decreasing? So what interval is f decreasing? -1 to 2. So as I look at my multiple choice answers, I know it's not A because it's from -1 to 2. B is okay. C is okay. D is okay. E is bad because it's above 2. So I could go through right now and eliminate some choices. It's either one of the three in the middle. All right. Once I've done that, now I'm doing concave up. Which derivative are we talking about for concavity? Second derivative. So I took this thing right here. I'm doing concave up now. So I took this derivative and found f double prime. So it became 12x minus 6. And I did the same thing again. I set it equal to 0. And I solved, so I added 6. I divided by 12. X is 1/2. So on my number line, now I'm doing an f double prime number line. I plugged 1/2 in there. I checked above and below. I plugged in negative a bajillion and positive a bajillion and see what happens, negative and positive. Is 1/2, what's 1/2 going to be considered? It's a point of inflection because the second derivative changed sign. So that's not important here, but just a good check. So that's a point of inflection. I want to know concave up. So where on that thing is it concave up? 1/2 this way. Because it's positive here on this interval, from 1/2 that way, it's concave up. So I want to know where do they overlap? From 1/2 and above, and from -1 to 2. So from 1/2 to 2 is when they would match up with each other. That's why the answer is D. Make sense? Where'd I lose you, Sydney?
No, I was looking at 18.
Okay.
So I was trying to
Okay, on number 16, so it's going to be very much like the one we just did in terms of what I asked for. For what graphs is this thing have a point of inflection? And so to do point of inflection, we're talking about the second derivative. So first thing I did with this equation was I found the first derivative. Multiply by 5, decrease the exponent, all that good stuff. Once I found the first derivative, then I found the second derivative, because I don't really even care about the first derivative. I just want to know about the second derivative. Once I got to that point, I want to factor it, set it equal to 0, and solve. So both of them had a 60 in them, so I took a 60 out. Both of them had at least x squared, so I took x squared out. So I factored out that 60x squared. I had x plus 2 left over. 60x squared is equal to 0 at x equals 0. And then obviously plus 2 is -2. Kind of makes sense at that point, Julia? All right. Once I've done that, I go number line, just like I did before, f double prime number line. I put -2 and 0 on the board. I plugged in things to try to figure out what was going on. And if you're smart about this, you know at 0, it's not going to be a point of inflection because it's x squared. That gives you like a parabola shape, which would not cross the x-axis, so it wouldn't change signs. So 60x squared would not work. It wouldn't change signs there. It did change signs at -2, so -2 is my only point of inflection. X equals -2. So on 18 is the fundamental theorem of calculus. If you look at what it says here, on 18 it says take the derivative of this integral. Okay, remember, like if I said take the square of a square root, those things are going to cancel. And we know that pretty much they're going to cancel. The only difference here is, remember, you want to have x in your numerator on your bounds. If it's not in your numerator, you got to flip it, change signs, but it is in the numerator, so we're good. So all I did here was I took this and I plugged it in for t. So I took that right there and plugged it in for t, so it became square root of x squared. But then the other thing you got to do is you got to multiply by the derivative of whatever you plugged in. So since I plugged in square root of x, all right, that's the same thing as x to the 1/2 power. I had to multiply by the derivative of this, which is 1/2 x to the negative 1/2. All right, so it was the same thing with that plugged in times the derivative. So in this case here, know what that means? It means I'm going to have a 2 on bottom because it's 1/2. So I could eliminate any of them, like C and D, that don't, and E. None of those have a 2 on the bottom, so you know it's not any of those three. My other choices are A or B. They look almost identical to me. Oh, there we go. Why is it A and not B? Yeah, I'm square root of x and I'm squaring it. So when I square the square root, that would cancel out, leaving me just x and not the square root of x. Again, those look really hard and they're actually really easy. Here we go. Looking at 19, this is an area problem. They're giving you an f graph and then they ask you for the average value of f. All right? So the key there is average value, and they told you f. They told you f, they want the average value of f. Okay, like if they tell you velocity, you want the average value of velocity. That's when you integrate it, okay, and then you do 1 over the upper bound minus the lower bound, or in this case, multiply by 1/8. I'm finding the average, just like average tests. If you took 3 tests, you divide by 3. In this case, you're going from 0 to 8, so I divide by 8. 1 times 1/8. So if I want the average value, all I did here is it says the area is 14, the area is 16, the area is 50. So 14, 16, and 50. If I want to do area here, I would take 14, and then what would I do? Subtract 16 because it's below, add 50 because it's above. That gets you 48. And they're trying to trap you into it. Letter E is 48, but you know you don't want 48. You want to divide that by 8. So 48 divided by 8 would get me 6. So 21, I changed it when I made my key, and I made them closed intervals on the end, just so we got more practice with that, because I felt like if you ever forget something that's going to be an end point, it's an f prime graph. You're trying to figure out maximums or minimums, so they can happen, maximums and minimums can happen at endpoints, or when f prime changes from positive to negative, since we're doing a maximum. Okay, so f prime, oh, I labeled that wrong, didn't I? Oh, yeah, that's bad. F prime, that's a minimum. And that's a maximum. Sorry. So that's the wrong answer. So the answer is not -3. What's my answer really going to be here? My answer is 1. Yeah. So my endpoints are good, but that doesn't matter here. I want where it changes from positive to negative, what should have been 1. Sorry. Make sense? You're going to alternate. Yeah, so these would be different too. Oh, my. All bad. Yep. Just playing. Let's go back and fix all that too. Max. Min. Number 20, it says this is f. I'm talking about h being the integral of f from 0 to x. So if this is f, okay, and if I integrate f, I get h. That means that I could also describe this graph as h prime. So this is an h prime graph. So I want to talk about each thing, h at 2, h prime at 2, and h double prime at 2. So I'm looking at this spot right here. If I want to know h, and I've got h prime, that means I'm looking at the area under the curve. Okay, and you can see that right here. It says h is the area under the curve. So that's going to be positive because you would go from 0 to 2, that's a positive number. I don't really care what it is at this point. I just care that it's positive. So h of 2 is positive. H prime at 2. This is an h prime graph, so what would you look for on an h prime graph to talk about h prime? It's an h prime. I want to talk about h prime, so I just go to the dot. H prime at 2 is 0, done. I said it wrong. Yeah, I just didn't finish my statement. And then I want h double prime. H double prime on an h prime graph means I'm looking at slope. So slope at 2 is negative. So I've got positive, 0, and negative. I want to put that in order. H double prime. So a negative answer is less than 0 is less than a positive answer.